Hello my dear students, welcome back to Fluid Mechanics lecture series. I am your Sumam. Today we are starting Fluid Kinematics. So this is the introduction class of Fluid Kinematics. Fluid Kinematics deals with the study of fluid motion without considering the forces which causes the motion. It studies how the fluid flow and how to describe the fluid motion. So fluid kinematics describes the geometry of the fluid motion in terms of displacement, velocity and acceleration of the fluid particle without considering the forces causing them. Before going to describe the fluid flow, let us discuss the type of flow. Unlike solids, fluid particles are moving with a different acceleration which are changing with respect to space and time. The motion of the fluid particle in space may be defined in 3 dimensions in the direction of 3 rectangular coordinates x, y, z drawn from the position of the particle at any instant. Now how to describe the fluid motion? So with the help of these coordinates and time, it is possible to describe the fluid motion with the help of 2 approaches. One is Lagrangian approach. The first and the most familiar way to describe the fluid motion is to trace the path of the individual object. So in Lagrangian approach is a natural way to describe the motion of solid object. The second method is Eulerian approach. It concerns fields. Here we are considering field variables which are changing with respect to space and time. That is properties, velocity, acceleration, pressure, etc. that varies with respect to space and time within the field. So in Lagrangian approach, we must track the position and velocity of the individual fluid particle. Let us go and see this an illustration. Consider the birds on the pool table which collides with another. The Newton's laws are used to describe the motion of this object, and we are able to predict where they will go and how the kinetic energy and momentum are exchanged from one to another object. Kinematics involves keeping track of the position of this object and velocity of this object. So when we apply this method to the flow of fluid, it is called Lagrangian approach after the Latin mathematician Joseph Louis Lagrange. In Lagrangian method, a single fluid particle from the flow is selected and its flow characteristics, that is velocity, acceleration, pressure, etc. are observed during the course of flow through the space. So that means we have to attach a moving coordinate system to the fluid particle. It is similar to an observer who is sitting in a moving boat and studying its motion. One of the examples is we are considering the motion of the cyclone from north zone to south zone. So during its motion, its properties are changing spatially and temporally. So in Lagrangian approach, information concerns the nature and behavior of the fluid particles, or we must track the position and velocity of the individual fluid particle. As you can imagine, it is very difficult to trace the path of the individual fluid particle. It is not like balls. Unlike solid, fluid particles are moving. So it is very difficult to define and identify the fluid particle or any individual fluid particle as they move around. And another thing is fluid is assumed as continuum, that is continuous distribution of matter without any void and space. So it is very difficult to define the interaction between the fluid particles. So the interaction between the molecules are not easy to describe. So Eulerian approach is more common. In Eulerian description of the flow, a finite volume called a flow domain or control volume is defined through which fluid flows in and out. That means in the flow field, we are defining our own space and we are just observing the field variables which are changing with respect to space and time. So this is a control volume. where the flow is coming in and flow is going out. So inflow is coming in and outflow that is going out. We need not keep track of the position and velocity of the mass of the fluid of fixed entity. Instead, we are considering the field variables which are changing with respect to space and time. So pressure is a scalar field variable which are changing with respect to space and time, and velocity and acceleration are the vector variables which are also changing with respect to space and time. Eulerian approach is similar to an observer who is sitting on the bank of the river and studying the motion of the boats passing through the fixed point. Or one of the example of Eulerian approach is defining the temperature of a particular region. So in that case, the space is fixed. So this approach concerns fields, that is properties like velocity, pressure and temperature that vary in time and space. So in engineering, compared to Lagrangian method, Eulerian approach is simple and it has many applications in engineering field, and it is very easy to convert into mathematical equations. So most of the engineering applications follow Eulerian approach. For the time being, for the time being, it is enough. Thank you. We are continuing fluid kinematics. Our next video is regarding the type of flow. Please press the bell button to get the notification. See you in the next class.